hopefully tonight is only 8 problems. And the instructions are write the equation of the parabola and graph. The first 4, it says the focus, they give you the focus, and the directrix is y equals to a value. For 5, 6, 7, and 8, the directrix says x equals to a certain value. And we're going to see some of that today. Copy that, please. All right, here we go. Our objective for today, I can write and graph a quadratic equation of a parabola. I can write and graph a quadratic equation of a parabola. So, as we started last week, we started deriving the quadratic equation of a parabola. Yesterday, we did graphing vertical and horizontal parabolas, and we wrote the equation for those. Okay? We don't need a parabola since we already know what parabolas are, right? Definition is all equidistant points away from what? 2 things. A point and a line. A point and a line. Exactly, the focus and directrix. And the example given, I gave you guys the focus, directrix, and I said, with that, we can graph our parabola. Okay? So we started with these, and we had to do all this work. We needed to sketch our graph. We needed to derive it by using the distance formula for each of the distances, d1 and d sub 2, and then we ended up with these. However, at the end, I said we're not going to be looking at it as y equal to, because they wanted written in a particular form, and we use this form, x squared equals 4py. So for my vertical, we use that one, and for my horizontal, we use y squared equals 4px. These 2 we use plenty, and yesterday's practice was on that. Now, we did some practice like this, and just to recap, to make sure everybody understands where we're at. So the focus is 0, 2, 0, 2. Oh, sorry. 0, 2. The directrix is at y negative 2. I mean, there's a straight line going through that point. And hopefully by now, with the practice you had last night, you understand that the parabola is always opening away from the directrix. Here's the directrix. It's opening away. It's either opening that way or this way. However, it's going to open towards the focus. Where's the focus? Over here. So that means our parabola is going to do something like that. Away from the directrix, but towards the focus. Yes? Yes, Mr. Q. All right, good. And then if we do something with a horizontal one, here's one that's horizontal. I'm going to sketch the focus. The focus is 5, 0. Directrix goes through x negative 5. There it is. Yes. The focus is over here. That means that the parabola is going to open towards the focus, away from the directrix. And it's going to go something like this. Yes? All right. And what did we know? We knew that all of these, the ones that we practiced yesterday, the ones that you did by yourself, they all went through the point of origin, which was 0, 0. So that's why we have a vertex at what? 0, 0, and these are our 2 equations for the vertical and the horizontal. Any questions up to right there? All right. Today, I'm no longer going to give you parabolas with vertex at 0, 0. I'm going to change the values now, which means I'm going to give you the vertex being another number for the x and another number for the y. So for right now, in order not to give you any different number, I'm just going to change it to variables. Remember the vertex, what were the values? H and K. Are we there so far? Everybody understands that I'm just writing H for a certain value and K for a certain value. So what does it do to the original? Look at the original. Look at the new one. It changes it. Look at it. This is the original. This is the new one. This is the original. This is the new one. What is the only thing that changes? For X, the change in what? H. And for Y, the change in what? K. That's all we did. So what happens From here, look up please, from here to here, what did we say? We just switch the x for the y, and we got this, right? So guess what's going to happen when we have our horizontal new parabola? What's going to switch? Not just x and y, the y minus k and the x minus h. The whole thing switches. You guys see it? All right, write these two down, please, the last two. We're going to be using those from this point forward. Copy that, please. Go. All right, just to make sure we got it, you copied the vertex hk, because that's what we need, and you copied both equations for the vertical and horizontal. Okay? So here we go. Top left of your graph paper, write example 1. Write and graph the equation of the parabola with focus 3, 2, and directrix at y equals 0. Focus 3, 2, and directrix at y equals 0. Copy that. All right, here we go. Writing utensils down, look up to the screen. All right? Let me get started, and then I'll have you guys copy. Please, pretty please. Because it has a lot of little components, and if you don't focus, you're probably going to miss part of it. All right, here it goes. So, let me move this up so you guys can see from back there. And it goes. First, the very first thing we did with last night's home play was plot our focus. Oh, sorry. Let me switch that. Plot our focus in red and graph our directrix. So what is our focus? 3, 2. 3, 2. Do that with me. 3, 2. The directrix goes through y equals 0. Y equals 0 is right here. That means there's a straight line going through y equals 0. There it is. Does that seem familiar? Yes. The second thing you did was to write your equation, because now you can identify what kind of parabola is this. This parabola is going to open up. Do you guys see that? The focus is up here and away from the directrix. So this is a vertical parabola. Therefore, I'm going to leave about 5 lines of space for those of you that are taking notes. And I'm going to write my equation. What's my new equation now that we have a vertex that is not 0, 0? It's x minus h squared equals 4p parentheses y minus k. All right? No. Are we there so far? Okay? So, writing utensils down, look up to the screen. So if you notice, this focus is no longer either on the y-axis or the x-axis as last night's home plate. Now it's off. What does that mean? That our vertex for the parabola is no longer on 0, 0. It's going to be somewhere over here. However, let me zoom in. What did we say? We said that in order to graph our parabola, there are equidistant points between the focus and the directrix. And obviously, there must be a point in between these two, halfway through. Is that correct? Do you see it right there? That is known now, not as a midpoint. This is known as the vertex. Label that, please. Vertex. And that is in between the point on the directrix and the focus. Hold on for a minute. All right? Any questions up to right now? This is something that we already saw since Friday, so this should be familiar, yes? Okay. So, let me go back and zoom out. But what do you notice on our equation? That we need what? H and K. That means we need the values of the vertex, and we also need a value for P. So this is what we're going to do. Underneath where you wrote focus, you're going to write vertex, open parentheses. Underneath the vertex, you're going to write Directrix for the point that's on the Directrix. And below that, I'm going to write P because I need to find a value for P. So far, so good? Yeah. Okay. So we need to find all these values. So let me show you something. Hopefully you see it. Writing utensils down, look up to the screen. Or you're going to miss it. Let me zoom in over here. All these 3 points are part of our process to make our parabola. Is that correct? What do all 3 points have in common? Talk over your neighbor. What do all 3 points have in common? Who saw it? They all have an x value of? That is correct. So I write 3 there and 3 there. All right. Now let's continue with stuff that we know. What else do they give us? The directrix y equals 0. So here's y equals 0. But this point is at 3 what? 0, because y is what? 0. So I place that right there. So I'm done with my directrix. There it is. Now, all I need to figure out is P, and for the vertex, the variable K. Some of you are like, where do you get K, Mr. Q? Let me show you again. The vertex is what? H, K. So what is the only thing we need to solve for? K. All right? So let me show you how to find P. P is the actual distance between the points. How do we find that distance? Look up, please. Here goes the process. Writing the utensils down. You're going to miss it. I take the y value of the focus and the y value of the directrix. I subtract them like if I was trying to find the slope. You guys remember that? So I do 2 minus 0. However, how many distances do we have between the focus and the directrix? How many distances? 2, from here to here and from here to there. That's why I need to divide by 2. So this is 2 over 2, which is what? Copy that, please. All right. So now we have most of them. What's the only thing that's missing? The K of the vertex. Let me show you how to find that. Writing utensils down, look up, please. Now, I can do an activity to show you guys how to get all the little formulas, because it's just patterns by looking at distances and such. But that'll take us maybe 2 more days. So I'm just going to show you the process on how to find K. Here it goes. Look up, please. To find K, I'm going to point this way so that I can show you the work. You're just paying attention. You do K plus P, and that should equal to the y value of the focus. What is the y value of the focus? 2. What is P? 1. So I bring everything else down. K plus 1 equals 2 minus 1 minus 1. K equals 1. That goes right there. Copy that, please. So, now check this out. Our noodle, our brain, usually wants to find shortcuts than doing all that work, right? Couldn't we, let me show you something. Couldn't I just have you write the coordinates here? Yes, right? Yeah. However, we're not just doing it by graphing. We're doing that by what? Algebra. That's why you're in Algebra 2. So you need to show it algebraically. Are we there? Yeah. So now that we have those, let's double check to make sure it worked. This is that the vertex is at 3, 1. Let's see. 3, 1. Yep, it's right there. Focus is 3, 2. And directrix is 3, 0. 3, 0. Yep, they're all right there. For right now, let's just graph a parabola just so that we can see it. Do that, please. You're like, Mr. Hugh, we don't have to do the points for right now. We don't. I just want to make sure that you see it, number one, and number two, that we know how to write our equation from that. Okay? All right. And the last part. Ready? Writing utensils down. Look up. What's next? All we have to do is what? Substitute values. Here we go. X minus, what is H? 3 squared equals 4 times P. What is P? 1 times Y minus K. What is K? 1. We end up with X minus 3 squared equals 4 times Y minus 1. And that's my equation to the parabola. Copy that, please. No. All right, here we go. Example 1Q. Copy that one, please. You don't have to copy the instructions. You already have them. We're going to do this one together. Focus 5, 4, and directrix going through y equals 0. Focus is at 5, 4, and directrix going through y equals 0. So, in red, let's plot our focus. Focus is 5, 4. 5, 4. There it is. All right. The directrix is going through y equals 0. Y equals 0 is here. That means there's a straight line going through y equals 0. There it is. All right. So, which way is that parabola going to open? It's up, so it's a vertical, so we write our equation. X minus h squared equals 4p parentheses y minus k. So what values do we need? H and k. That means we need a what? A vertex. What else do we need? We need a point on the directrix. So I'm going to write directrix. And what else do we need? We need a value for p. Okay? So, with that said, what is the obvious point that we know from the directrix to the focus? It's right here on the directrix. And our midpoint, we know it's the vertex between these two should be about right here. And what do we know that all three of them have in common? The number 5 of x. That is correct. That's the first thing we fill in. What else do we know? The directrix y value is what? 0. Let's see. 5, 0. Yep, there it is. All right. Let's see if we remember how to find p. We take the y value of what? Of the focus. And the y value of what? Directrix. We subtract those, 4 minus 0, and then we divide by 2, because it's how many distances? 2 distances. 4 divided by 2, so this is 2. All right. So, now that we have our directrix, we already have our focus, we have P, now we need to solve for what? K. How do we find K? K plus what? P equals to what? The y value of the focus, which is 4. What is P? 2. Bring down the rest. K plus 2 equals 4 minus 2. K equals 2. That goes right there. Let me plot this to see if it's true. 5, 2, 5, 2. Yep, there it is. Let's graph a parabola just so that we can see it. It's not exact, but at least so we can see what it's going to look like. There it is. All right. And what do we need to do at the end? Substitute values and simplify. Parentheses x minus, what is h? 5 squared equals 4 times p. What is p? 2. And y minus k, what is k? 2. So this is x minus 5 squared equals 8 times y minus 2. And this is our equation. Show me your parents how comfortable you are with these. Okay, 5s, 4s, 5 4s, okay. Now, once again, our noodle wants to do shortcuts. Let me show you the shortcut that some of your noodle is doing. Look up. Some of you looked at and you're like, P is 1 and K is 1. P is 2 and K is 2. Yeah, your noodle wants to do that for some of you. But that's not going to work when they change the value of the directrix. So make sure you follow your process. Next, copy this one, example supercube. Let's see how you do with that one. Focus 4, 5, and directrix goes through y equals 1. I'll give you a head start. Copy that and go. All right, let's see. I gave you a head start. Let's see how you did. First thing with red, we plotted our what? Focus, 4, 5, which is right there. Second thing we did, we graphed our directrix going through y equals 1. Y equals 1 is right here. That means there's a line, straight line going through y equals 1. There it is. Notice that this is different from the ones that we just did, just a tiny bit. All right? And what else? Therefore, it's a vertical, so we write x minus h squared equals 4p and y minus k. From there, what do we need? Values, we need h and k, so that means we need a vertex. What else do we need? We need a point on the directrix. But what did we find out with vertical parabolas? That all of them, the x value is the same for all three. So we write what? 4 and 4. I forgot p. We need a value for p. So all of them have x value of 4. Is that correct? All right. What is the y value for the directrix? 1. So let's plot this one. 4, 1. 1, 2, 3, 4, and 1. Is it on the directrix? Yes. Is it straight aligned with the focus? Yes. All right, let's find P. How do we find P? Take the y value of the focus, the y value of the directrix, 5 minus 1, 5 minus 1, and divide by 2. 4 divided by 2, so P is 2. Yes? Because between the focus and directrix, there's a midpoint. Is that correct? Yes? And between the focus and the midpoint is one distance, and from the midpoint to the directrix is 2 distances. So that's why we need to divide by 2. Okay? So let's find K. How do we find K? It's K plus P equals to what, everyone? The y value of the focus. All right, what is P? 2. Bring everything else down. K plus 2 equals 5, minus 2 minus 2. K equals 3. That goes right there. Let's plot our vertex. 4, 3. 4, 1, 2, 3. Is it midpoint between those two? Yes. All right. Before I plot my parabola, let me write my equation. I got x minus h is 4. 4 times p, what is p? 2. Y minus k, what is k? 3. Therefore, x minus 4 squared equals 8. Y minus 3. This is the equation to my parabola. Hands if you got that. Okay, good. Now, for tonight's home play, I want you to do all this. I want you to do this. But for the graphing, pay attention to the graphing. For the graphing, I want the 3 points, but then I want my parabola, but I want you to show me work for at least one more point. Pay attention. Here it goes. Ready? My parabola is going to go through the vertex, is that correct? And away from the directrix. What does that mean, Mr. Q? That the vertex splits our parabola in half. These points are going to reflect over here. So if I was to solve for a point right here, don't you think there's going to be another point right about there? Yes. So what does that mean, Mr. Q? That I need to choose a value for x on this side of the parabola and one on this side of the parabola. So I'm going to choose one that's 2 steps away for right now. What x value is 2 steps away from 4? 2. How about on this side? 2 steps away is 6. So I'm going to use 2 for right now so I can plot my point on this side. How do we do that, Mr. Q? I need to use my equation. X minus 4 squared equals, what was it, 8? Y minus, what is it, 3? Was it 3? All right, but instead of x, what am I going to write? 2 minus 4 squared. What is 2 minus 4? Negative 2. What is negative 2 squared? 4. And all that equals 2, 8 times y minus 3. You'll copy right now. Give me a second. Check this out. How do I solve here? I divide by 8, divide by 8. Don't distribute or else you're going to do extra work. So here we're left with what? 1/2 equals y minus 3. What's my last step? Add 3, add 3. So I'm left with 3.5 equals y. What does that mean, Mr. Q? That when x is 2, y is what? 3.5. So let's see. When x is 2, y is 3.5, which is right there. So that means my parabola is going that way. But on the same token, when x is 6, what is y? 3.5. It's the same value because it's reflecting. Does everybody see that? And now I can sketch my parabola. Yes? Yes. For all of them, I need at least one point with work and the other one reflected. Copy that. Show me what how come you are with that so far. Yeah, 5 4s, 5 4s. Choose. Yeah, you need to stay in class, please. 5 4s, 5 4s or so, right? All right. Let's do another one, but now I'm going to give you one in a different direction. Oh, yes. Do I zoom in? Hurry up, please, hurry up. So basically, it's just substituting the x value to get the y value. So some of you are wondering, Mr. Q, what value do you want us to use on either side? Go at least 2 to 3 on each side. So I could have chosen what? 1 and 7. Or I could have chosen what? 2 or 6. Either those two. All right? Copy this one. Example 2Q. Focus is 5 4. Directrix going through x equals 1. Will you dispute the interruption? Copy that. All right, let's do this one together. Here we go. What do we plot first, everyone? 5 4, which is our focus. And let's graph our directrix going through what? X equals 1. X equals 1 is right here. There's a straight line going through that point. That means this line is a vertical line. So what do you guys notice now? That the parabola is going to open which way? To the right. It's going to open to the right. Do you guys see the focus over here? So what does that mean, Mr. Q? That I need to write my other equation. Parentheses, y minus k squared equals 4p, parentheses, x minus h. But we still need the same value, Mr. Q? Yes. Vertex directrix point, and P. Question now. Look up, please. Can everybody picture a point here on the directrix? Can everybody picture a point, midpoint there? What do all 3 points have in common now? Y value of 4. That is correct. So now it's going to change. Now all the values of Y are the same. All right. So what is the X value of the directrix? 1. So let's plot this. 1, 4. 1, 4. Is it on the directrix? Yes, there it is. Let's find P. Yes? All right. So therefore, we're done with P. How do we solve for H? Think about it. Let me go back to this one. For K, we did K plus P equals 5. What do? Talk it over to the neighbors. Talk it over. Okay, we got it? So we do what? H plus P equals 5. Because now we are in what value? On the X value. Yes? So what is P? 2. We got H plus 2 equals 5, minus 2 minus 2, H equals 3. Let's see if it's true. Vertex. 1, 2, 3, and 4. Is it 3 and 4 midway between them? Yes, that is true. Let's write our equation. Parentheses y minus, what is k? 4 squared equals 4 times 2, and x minus 3. Y minus 4 squared equals 8, x minus 3. Good one, guys. Enjoy your home play. There is tutoring today. If I don't see you, see you guys tomorrow. Bye. Be nice. Oh, here goes the home play again. There it is. All right. Bye.